welcome to our channel Euclid Mathematics. We have started lecture series on previous year question from JW, NET, SET, GATE and other competitive exam. I already uploaded plenty of the videos on my channel, so if you wanted to see this video, you may check it into my playlist. Now in my today's video, we are going to learn one of the question from real analysis. It is very easy question that we have to apply some standard result that we get the very easy answer. Okay, now let's get started with today's solution. Question, we'll see the question and then we'll go for the detailed understanding of solution. Our question, we have given limit n tends to infinity, k running from 0 to n upon k square plus n square. Okay, so we have to find out a limit under summation. Okay, so we have to find out the summation and then we have to apply limit. Okay, so question is from the paper third, that means 4.75 marks question, and multiple correct question. Okay, that means multiple answers are correct, maybe two or more than two options are correct. Okay, so let's get started our solution. We'll see detailed steps of our solutions. One question here, k is equal to 0 to n upon k square plus n square. We have to apply limit, and first of all we have to apply summation and then we'll get the limit. Okay, so if we're going to solve this question directly, it is quite difficult to get the answer. Okay, so for finding such a solution, we have to apply some of the results from real analysis. Okay, and this is one of the famous result from real analysis that we can apply here for finding the solution. Okay, so here we know the result that it says that when we have limit as n tends to infinity, 1 upon n summation r running from 0 to n f of r by n. Okay, so when we have such a summation, then we write integral over 0 to n f. Okay, for finding such a summations, we write this way. Okay, so we have to replace our given term with this term. Okay, so how can we transfer our term here in this term? Okay, now let's take n common from our term. Okay, n common from our term, that means we want 1 by n over here. Okay, so 1 by n it will come here then, and then we'll go for the f of r by n. Okay, so here we can see we want the limit as n tends to infinity series k running from 0 to n under bracket n upon k square plus n square. Okay, this one is the bracket over here. Okay, take n common from here. Okay, so n means we have to take n square common, then this n will also get cancelled. Okay, so what we will get, limit as n tends to infinity, okay, series n k running from 0 to n. Okay, so 1 upon n square common here, 1 upon n square common under bracket n upon k square by n square plus 1. Okay, so what I have done, taken n square common from here, n square common from here. Okay, so this n get cancelled with the single n, and we'll get left here with the value limit as n tends to infinity. Okay, 1 upon n get common here, so series k running from 0 to n, so 1 upon n it is left here, which is get cancelled with this term, so 1 upon, so n square, k square plus n square by n square. Okay, k square plus n square by n square. So I written here this into this plus this, so k square plus n square by n square. Okay, so this is the next term. Now what we have to do, just go for the simplifying the term. Okay, so what we have over here, limit n tends to infinity, compare it this one, this term. Okay, limit n tends to infinity, 1 upon n as it is here, k running from 0 to n, k running from 0 to n, f of r by n. So I got the value for f of r by n, it is here. Okay, so what is the value for f of r by n? 1 upon k square plus n square by n square. Okay, so denominator it comes numerator. Okay, so apply this step, I got the value for f and apply O integral over 0 to 1. Okay, now we got the f of x as 1 upon 1 plus k square by n square. Okay, now what we have to do, we want the value for f of r by n. Okay, so for finding just for finding the f of r by n, that means integral over 0 to 1 f. Okay, so we have to go for some substitution, because substitution is needed here for finding the integral. Okay, so put some value for k by n, put k by n is x, then k square by n square it comes as a x square. Okay, so we can write f of x as 1 upon 1 plus x square. Okay, f of x as a k by n. I put it here x. Okay, so it is k by n here, k by n it is here. Okay, and it is here, so I put it is x 1 upon 1 plus x square. Now what we have to do, the value for f of x which I got it here, so we have to replace it is here into the integral. Okay, 0 to n integration f. So we'll get the 0 to 1 integration of p of, so integration of this term. Okay, 1 upon 1 plus x square. Okay, into dx. So we want the integration of this value. Okay, so for finding the integration, go for the standard result. Integration of 1 upon 1 plus x square, it is the having standard integral as a tan inverse of x. Okay, so we'll get the tan inverse of x, which is the integral. Okay, under bracket 0 to 1. Okay, so replace x by 1 and then replace x by 0. So tan inverse of 1 minus tan inverse of 0. Okay, so we'll get here tan inverse of tan of pi by 4. Okay, tan of pi by 4 I written 1. Okay, and tan inverse of a tan of 0. Okay, tan inverse of tan 0. Okay, tan 0 is a 0, so tan inverse of 0 0, so this term totally get 0. Okay, so we get the tan inverse of a tan pi by 4, so it comes here only the value pi by 4. Okay, so we got the correct answer here as a pi by 4. Okay, so this one is your final answer. I hope you all have understood my complete solution. So if you wanted to see the solution, I will show you my written solution. So here it is the complete solution of my example. For your better understanding, you may refer this solution. I hope you all have understood my today's solution. Nothing is difficult over here. So even after if you found anything difficult, let me know in comment section. I will come up with some other videos. So thank you everyone. Thank you for my today's lecture.